Today we're starting Chapter 2 of our notes. We'll actually be covering pages 1, 2, and 3 of our Chapter 2 notes packets. We'll be working with rational expressions in this chapter, and you've worked with rational expressions last year in Geometry Honors, so we're going to go through the operations of multiplying, dividing, adding, and subtracting rather quickly. And we'll spend a little more time on the new material, and that is solving equations and inequalities containing rational expressions. So we start off by, well, first, what is a rational expression? It's the quotient of two polynomials. And you have 4 examples listed here. Recall that in a rational number, a over b, a and b are integers, b not equal to 0, right? The denominator cannot be 0. In a rational expression, a over b, a and b are polynomials. Again, the denominator may not equal 0. Recall, division by 0 is not possible. A rational expression whose denominator is 0 is meaningless or undefined. For what value or values of x in each expression is not defined? Take number 1. Again, we are simply looking at the denominator, concentrating on the denominator. For what value of x, if we replace x here in x minus 3, will this expression be undefined? Well, of course, if we replace it with 3, when x equals 3, it would be undefined. X plus 2 divided by x squared minus 16. Focus on the denominator. For what values of x would this be undefined? Well, when is x squared minus 16 equal to 0? Well, you can recognize this as being the difference of two perfect squares. We know that 16 subtract 16 would result in 0. So we can say 4 squared, but there's also negative 4 squared would result in 16. So one way of doing this is, as I just mentioned, or you can factor. And then if we replace this x with negative 4 and the other one with 4, our denominator would result in 0. Number 3, 2x minus 1. And if we wanted, we're not sure, take the denominator, set it equal to 0, add 1 to both sides, divide by 2. When x is 1/2. 2 times 1/2 would be 1. 1 subtract 1 is 0. Add number 4. When would x squared minus 4x equal 0? For what values of x? Well, again, if we factor, when x is 0 or when x is 4. Reducing to lowest terms. A rational expression is reduced to lowest terms, or is stated in simplest form when its numerator and denominator have no common factors other than 1 and negative 1. To reduce a rational expression, you factor both numerator and denominator. This is key here. Right, you factor first. You don't try dividing out terms. Rather, you divide out factors. Once numerator and denominators are factored, you may divide out common factors. So number 1, to simplify, there's a GCF in the numerator. Factor out the 2. X minus 3y is the other factor. GCF in the denominator of 4. X minus 3y is the other factor. Now these x minus 3y's are common to both numerator and denominator, so they divide out. And the 2 and the 4 reduce. 2 and the 2 once, 2 and the 4 twice. So our answer is, our simplified answer is 1/2. Number 2, GCF of 4x in the numerator. X plus 2. Denominator, GCF of 6x squared, x plus 2. The x plus 2's are common to both numerator and denominator, so they divide out. The x in the numerator divides out with one of the x's in the denominator, and the 4 and the 6 reduce. So we have 2 over 3x. So the key here to this chapter is you have to be able to factor flawlessly. It's very, very important. Number 3, difference of two perfect squares, x plus 5 times x minus 5. GCF in the denominator, 3, x minus 5. X minus 5 is common, they divide out, so we're left with x plus 5 over 3. Number 4, the trinomial. Factors of 3 that add to 4 are 3 and 1. And the factors of 1 that add to 2 are 1 and 1. Now that we're in factored form, the common factor, x plus 1 of the numerator, divides out with 1 of the 2 in the denominator. So our answer is x plus 3 over x plus 1. The x's do not divide out. These are terms. This numerator is the binomial x plus 3. The denominator is something different. It's the binomial x plus 1. Page 2, number 5. Numerator, the trinomial, factors of 16 that add to 8 are 4 and 4. So x plus 4 times x plus 4. The denominator is the difference of two perfect squares, x plus 4 times x minus 4. And by all means, you're always welcome to stop the video and go ahead on your own, try the factoring on your own. So our end result, is x plus 4 divided by x minus 4. Number 6, GCF in the numerator, x squared y. X plus y is the other factor. Denominator, GCF of x squared y. X minus y is the other factor. Let's see, the x squared y divide out, and that's it. So x plus y divided by x minus y. Number 7, GCF of 3 in the numerator. And I get x squared minus 16 for the other factor. And the denominator, factors of negative 8 that add to negative 2 are negative 4 and positive 2. Now the numerator we can still factor. Recognize x squared minus 16 as a difference of two perfect squares. X plus 4 times x minus 4. And it looks like the only thing that divides out here are the x minus 4's. So our end result is 3 times x plus 4 over x plus 2. And number 8, 2x squared minus 9x minus 5. Okay, so this is a factor in, factor out. I actually have to do this. That's negative 10. The factors of negative 10 that add to negative 9 are negative 10 and 1. So this is sort of a side step here. So I draw my fraction bar, and this is just a factor. This trinomial, whose lead coefficient is not 1. So 2x minus 10 and 2x plus 1, and 2 divides evenly into 2x minus 10. Okay, so that's x minus 5 times 2x plus 1. That's the factors of my numerator. And the denominator is the difference of two perfect squares, 2x plus 1 times 2x minus 1. And the 2x plus 1's divide out. So our answer is x minus 5 or 2x minus 1. Now, factoring out a negative 1, again, you should have seen this in a previous math course. I have x minus 3 divided by 3 minus x. Now, there's a few ways of looking at this. I call these opposites. If I take the denominator here, let me just copy down the numerator. If I take the denominator and factor out a -1, what would I get inside parentheses? I would have -3 plus x. Well, now -3 plus x is the same as x minus 3, right? Positive x, -3, -3. So these would divide out, and we would just be left with 1 over -1, which is simply -1. Another way of looking at it is pick any number, say 7. If I replace x with 7, 7 minus 3 divided by 3 minus 7. What does that result? 7 minus 3 is 4. 3 minus 7 is -4. Well, that reduces to -1. Okay. So in number 10, when we have y minus x divided by 2 times x minus y, these here, I call them opposites. These are opposites. So they are going to divide out, and you simply replace with either the numerator or the denominator, replace with a -1. So this would be equal to -1/2. Next, number 11, factor the denominator. Get x plus 2 times x minus 2. Don't get tricked by this. X plus 2 and 2 plus x, they are the same. They divide out. They're just written in a different order, that's all. So this is equal to 1 over x minus 2. There are no opposites there. They're exactly the same. It's a +2, positive x, +2, positive x. Number 12, GCF here, xy, 2y minus 3x is the other factor, and GCF of the denominator, 2x, 3x minus 2y. These are opposites. 2y minus 3x, 3x minus 2y. They divide out. I'll put a -1 in the numerator, and our x's here divide out. So our answer is y times -1, -y, over 2. You can try 13 and 14 if you like, because next we're going to go into multiplying and dividing. 1 plus 3x, difference of two perfect squares, 1 minus 3x. GCF of x, 3x minus 1. These are opposites. They divide out. Replace with a -1. I'm actually going to move that -1 into the denominator, so that my numerator is going to stay 1 plus 3x, and I'll have -1 times x, which is -x in the denominator. Now the negative, it could have been placed in the numerator. It can also be placed out in front of the fraction. All three would be equivalent. Number 14, nothing to factor in the numerator, just bring that over. Now the denominator, that's going to take us the extra step here. 2 times -14 is -28. Factors of -28 that add to 3 are 7 and -4. Fraction bar, 2x plus 7, 2x minus 4, all divided by 2, and 2 goes into 2x minus 4, x minus 2 times, and our other factor, 2x plus 7. 2 minus x minus 2 are opposites, divide out. So this is equal to -1 over 2x plus 7. Okay, so that was just simplifying. So now, page 3, we look at the operations of multiplying and dividing. Again, we're going to factor numerators and denominators and divide out common factors to numerators and denominators. So we factor first. So number 1, x squared plus 4x. GCF of x, x plus 4. Denominator, factors of 9 that add to 6, 3 and 3. We have the operation of multiplication. Make sure you write that. Negative x minus 3. I'm thinking maybe I want to factor out a negative 1 there. See what happens when we do that. 8x plus 3. GCF of 8, x plus 4. Okay, so now that we have everything factored, we divide out common factors to numerator and denominator. So the x plus 4's divide out. The x plus 3's divide out. And that looks about it. So for our numerator, we have negative 1 times x, which is negative x. And our denominator is 8 times x plus 3. I'm going to skip number 2 and we're going to go on to number 3. Again, we have the multiplication of these two rational expressions, so we're going to factor the numerators and denominators and divide out common factors to each numerator and denominator. Number 3, the numerator, GCF of x squared, x minus y is the other factor. Denominator, GCF of y squared, y minus x, the other factor, times GCF of y, x plus 1, and GCF of y, x plus y. Now, dividing out, the x minus y and the y minus x here recognize as being opposites. So I'll divide those out and put a negative 1 in the numerator. Again, the negative 1 can go in the numerator or denominator. It does not matter. The y's here divide out. And that looks to be about it. So we have negative 1 times x squared, or negative x squared, times x plus 1, over y squared times x plus y. Now, number 4, we're multiplying 3 fractions here. So jump right in to factoring. Factoring the numerator, difference of 2 perfect squares, x plus 5 times x minus 5. Denominator, x minus 3 does not factor. Our next numerator, GCF of x, or excuse me, 6. X plus 2 is the other factor. Trinomial and denominator, factors of 10 that add to 7, 5 and 2. And our third fraction, numerator does not factor. Denominator has a GCF of 4 times x minus 5. Dividing out, what's common to numerator and denominator? X minus 5's divide out. X plus 2's divide out. X plus 5's. And one more thing, the 4 and the 6 reduce, dividing each by 2, 3, and 2. So our end result is 3 times x plus 3 over 2 times x minus 3. Next, dividing. Again, you've seen this before. What we're simply going to do with the division is multiply by the reciprocal. So in number 1, I have the first rational expression divided by, I'm going to change that division to multiplication, and we're going to write the reciprocal of the fraction that follows. So this is going to become x squared minus y squared over xy minus y squared. And the first fraction just stays as it is. Now we have a multiplication problem, so now proceed as if it's multiplication. Factor numerators and denominators. Again, you're always going to factor first. Okay, so the numerator here, our first numerator, has a GCF of x, x times 2x plus y, and the denominator of GCF of x squared Our other numerator is the difference of two perfect squares, x plus y times x minus y. Denominator, GCF of y, x minus y. Now, dividing out common factors to numerator and denominator. X plus y is here, divide out. X minus y is divide out. This x in the in the numerator divides out with one of the two in the denominator. And that looks about it. So we have 2x plus y over x times y. And that's our final answer. Next, number 2. And I have division. I know I'm going to change it to multiplication and write the reciprocal of the fraction that follows. All right, and now in that same step, this fraction stays as it is. I'm going to factor it. GCF of 4y in the numerator, y minus 1, and then the denominator, a GCF of 3y, y plus 2. So everything is factored that can be factored. Now we divide out y plus 2, y minus 1, and the y is there. So we're left with simply 4 divided by 3. Number 3, factoring the numerator, factors of -2 that add to +1 or +2 and -1. Denominator, factors of -3 that add to +2 or +3 and -1. I change the division to multiplication and make sure we're writing the reciprocal. So for my numerator here, I want the factors of our original denominator. Factors of 6 that add to -7 are -6 and -1. And the factors of -12 that add to -4 are -6 and +2. Everything is factored, so divide out. The x minus 6 are common, x minus 1s, the x plus 2s. So our answer is our numerator, x minus 1, divided by a denominator, x plus 3. Again, these x's do not divide out. They are terms. This is a binomial x minus 1, which is totally different than the binomial x plus 3. And lastly, number 4, we have division and then followed by multiplication. Okay, well, I know we're going to change our division to multiplication, and we're going to take the reciprocal fraction that follows. So let's do that. So, and I'm actually going to factor it. I'm going to do this in one step. So my numerator here is going to be the factors of the denominator, which is a difference of two perfect squares. 2x plus 3, 2x minus 3. And now my denominator is the factors of the trinomial. Factors of -12 that add to 4, x plus 6 times x minus 2. My first fraction, I'm factoring the numerator, difference of two perfect squares, x plus 6 times x minus 6. And the denominator, got some work to do here because the lead coefficient is 2, it's not 1. So we get 36. And then I'm looking for factors of 36 that add to -15, -12, and -3. I'm going to put this over to the side here. So that was a -15, so that's going to be 2x. -12 and -3 rather. -12 and -3. Okay, got it right now. Dividing 2x minus 12 by 2, we get x minus 6. So we have x minus 6 times 2x minus 3 for our factors. And then our last fraction, the operation in front of that was multiplication, and we cannot factor the numerator nor the denominator. Okay, so here we go. Anything that's common to any numerator and any denominator, we divide out. The x minus 6s, the 2x plus 3s, the 2x minus 3s, the x plus 6s, and then recognize 2 minus x and x minus 2 as opposites. So they'll divide out or replace with a negative 1. So we have simply negative 1 over 1, which is negative 1. All right, so that concludes our lesson for today. Again, we've gone over the operations of simplifying, multiplying, and dividing, and tomorrow we'll look at adding and subtracting.